Hello, humans. So, lately I've been playing around with the GameMaker, just working on a new prototype for a game and a possible tutorial series. And one of the first things I wanted to do to test the limits of GameMaker, because that's the engine we use, is to check, okay, can it actually do networking? And I was pleasantly surprised by how simple the networking was in it. And sure, I haven't pushed it to its limits, and I haven't done super much advanced stuff, but for game jam purposes, the things I'm gonna show you right now is fairly simple, and it took me like less than half an hour to do from never having done it in GameMaker before. So yeah. Alright, to explain the setup first, we can just start the thingy-madoodah. So right now I have a game. It's just a character that can run on a screen. Can anyone recognize the character?
It's the Factorio guy.
Yes, it's Mr. Factorio. Or Miss, I don't know. Yeah, could be a pregnant lady, I guess. But I'm guessing it's a beer belly. And that's a very simple, it's just a script so that it listens to the input on the keyboard and moves you around. Nothing advanced more than that. When you think about doing a network game, plan for it in the beginning. If you make a game first and then think about, oh, can we do this in networking now? You're basically gonna rewrite your whole game. So if you want to do networking, do it from the start. And what I usually do is I set up a character object. So this is the character that, this is a character. And then I make a local player and a network player. So I differentiate between okay, is the player local here or is it on the network? And both of them inherits the stuff from the character. In this case, it's very simple. It's like at the end of the update phase, pick the correct sprite depending on your current action, like what your animation is, and update the depth based upon your position in the y-axis, so that it sorts itself out, so that things are layered properly when it's rendered. Okay, let's start. First thing I want to do is set up the actual networking. That is, in this case, it's going to be super simple. We're going to try to connect to a server. If we can't connect to a server, we're going to start the server. And we do this locally. For this, I want to go into, okay, so I can explain. How many has actually used GameMaker here? 2, 3.5-ish. Okay. So I was very much against it when I started, but honestly, I love it more than Unity for now. But yeah, we're not doing 3D anyway, so who cares? So in the init room, there's 2 rooms. It's basically like the equivalent to scenes in Unity. In the init room, I just set up some basic stuff for for the sprites, so it's nothing fancy, and then just go to the next room. Normally, I would put all the setup and init stuff that, like, okay, before we actually start the whole game, do a bunch of setup here, set up variables. And we do the same thing in the world right now, because when you get into the world scene, as in, like, that's the game, that's where we want to start the actual server. So let's come on, keyboard. Set up networking. And this is, I just create a local player here, because even if you're the server or if you're the client, you're still a local player. So, so in this case, we wanna. I'm just gonna read my notes here, because so we're gonna do some config stuff here first, and just say that. Otherwise, we will be waiting a long while for it trying to connect to the server, which may or may not exist. So we'll give it like half a second to connect. If it doesn't work, then it doesn't work. So we create a global variable called socket, where socket is basically the ID of the communication port. So when you want to talk through the network, you reference to this ID, and it will know what you're trying to talk to or with or through. Sorry. So we create a socket. In this case, we want to do a network socket TCP. There's basically two major variants to care about. TCP and UDP. It's different protocols for how to transmit and receive data. TCP is the slower version, which also gives you an assurance that things happened. So you will send data, and the other one will say, I got the data. If it doesn't say that, it will resend the data again. This means that things are being sent two ways to make sure that it actually arrived, and it arrived in the correct order. Otherwise, you can use UDP, where you just just throw a package at someone and just hope that they receive it in the correct order, because internet is a big network, and it go like, okay, this package goes over here, this package goes over here, and they can arrive at different times. So TCP will make sure that it will collect the packages and okay, it should be in this order, and put it in. And UDP does not. So in this case, we use TCP because it's just a demo example. Normally, you want to use both. So you use UDP for things that does not matter, but is nice to have, such as position updates. It's not super important for the client to know where people are at all times. It's important that the server knows it, but not the player. The player can, of course, be frustrated if it's it's assuming that the player is here, but it's not. But usually UDP doesn't have that much issues that you won't actually get the correct answer. But it's just that way you can update the positions more often without caring about it. So we do that, and we actually want to connect. And we use our global socket. And in this case, we want to connect to this local host. For those of you who don't know, this IP address here is basically your computer. It's only accessible from your computer. We're going to say okay, if result equals 0, it means that it did not succeed. I think that if it's minus something, then it's successful. And then we're going to have okay. Oh, no. 0 is that it succeeded. Minus is error. That's how it is, yeah. So if we succeeded with connecting, then we are not the server. So we're going to let us know that, okay, we're not the server. And in that case, we want to spawn an object. And we just spawn it at 0 position. And that object is going to be called is a client. That's just an object that will just handle various network commands for us. And otherwise, we is server. And then we create a new socket by creating a new server. Okay, so the port, the 3000 is the port. You have X amount of ports, 65,000 ports on a computer. It's basically like a door. So every connection your computer has, going inwards or going outwards, it needs a port. So when you connect to a web server, for example, the web server has a door, it's door number 80. You will go there, hello, I want to come in and check out your website. Or it's 443 or whatever right now for SSL, for HTTPS. But you also have a door which you exit your computer to go to the other computer. And some of you might have experienced issues accessing web server websites when you have a bunch of websites open already, because you're using all your or you're using too many doors on your computer, more than it can handle, so it's not able to open a new door to get out to the internet anymore. It can happen. And in this case, we're gonna say door number 3000. That's our door. And hopefully you don't have something else that's blocking that door. For example, if you're trying to start a server, like a web server on your computer, it will want to use port 80. But then you have Skype that for some reason also wants to run a web server, and it will fuck you up. And if we are the server, then we create a server object. Great. So with this code now, we're now basically set up the networking. We try to connect to a server. If we can't connect to the server, we create a server. Simple. Done here. Next thing is, I'm actually gonna be able to write all this in time. And now our local player, when we create it. So when the local player is created, only we know that we are created currently. Sure, we've potentially connected to a server, but the server only knows that we've connected. It doesn't mean that we actually exist yet, because technically you exist on a certain position, and you might know your first position, or the server should keep track of your position, otherwise you can cheat. But in this case, you keep track of your position where you spawn. So we're gonna say that, okay, if we're not the server, then we're gonna send a little message. Try to explain this soon. So we're gonna send a message to the server that we're joining. Okay, enter this thingy here. This is a function I made myself. It's just a packaging function. So it will package the message we want into bytes and send it to the server. So in this case, we're sending to which socket, who are we communicating with, which is the server. The client, which is us, which is, since we don't have an ID ourselves, because we only know that we are we. The server knows which ID we are. We don't know which ID we are. So we're gonna say -1, because it keeps track of that anyway, so we don't need to send that. And then we will send it some information like, okay, I'm at this position, I'm looking this direction, okay? And the reason we do that is so that the server knows where we are, and it can tell all the other players where you are. Okay. I misspelled a comment in my code. Fuck this shit. Okay. So, okay, we have sent the message. Let's receive the message then. So now we are at the server, and we want to receive the message that a player has connected. I'm gonna copy some code because I'm not gonna be able to write this in time. explain the code still. So in this case, we take this one here. Swoop.
Calling.
Hello. Stop commenting. Is there a problem or not? That should be a problem. Let's go.
Programming, who knows?
No, it's not a problem. Just being an ass. It's because it doesn't. The function doesn't have code in it anyway. Okay, so in this case here, right now I'm in the server object, and then you add an event, which is basically like asynchronous networking. This event will be called every time you receive, like every time your game receives a message via networking. It doesn't matter which socket it's via. It's gonna receive, this event is gonna fire every time. So we have to make sure that we're only acting if we should be acting. So in this case, so if the ID of the message, which is gonna be the socket that's the message is coming through, is our socket. That is, in this case, the object server only exists if we are the server. Therefore, global.socket is our socket saying, hey, this is the port we're listening to see if incoming connections are here, or if they're disconnecting. So in this case, we can say, okay, either it's going to be a connect message or it's going to be a disconnect message. In this case, we're not doing anything on connect because connect doesn't mean anything until they've sent us another message telling us who they are and why they're here. However, if they are disconnected, then we're going to remove the client, of course, and send a message to everyone saying, hey, this player left. So that everybody knows that, hey, remove this person from your lives. So if it's not our server socket, then it's a message coming from someone else. It's another client telling us something. So we're gonna make sure that, okay, is it a data? Okay, yeah, they're sending data. You get the buffer, which we package in this the other function I showed you. We're gonna read the first byte. The first byte is gonna tell us what type of message are you sending me, and that's something. This message is something you composed yourselves. So in my case, I set up a little enum that just says, okay, you can have player join, player leave, and position. That's the three messages we're using here, as it's quite simple. So if it's player join, then we know that, okay, so if a client is telling me player join, then it's telling me, oh, that player is joining. So we're just going to read the X, the Y, and direction, okay? And then we're going to create a network player in this case. So instead of creating a local player, we create a network player. And we're going to let's put up some stuff like sockets. And a big difference here compared to our local player is that when you're dealing with your local player and you're updating the X and Y, you can do that directly. When you're updating a network player, you would want to set a target X and Y. You don't always know how far along they've been going there. So you tell them, okay, this is where they're at, and then you want to start moving them towards that direction. If you change the position directly, they're just going to like jump all over the place. So you let them just slightly move there instead over time. And so we create the network player, and we set the target X and Y. So hey, go towards that direction. But of course, when we're spawning it, we already set it to that direction, so it will already be standing still. Then, to the player who just joined, we're gonna send a player join message for every other player that's already in the game. So we're gonna tell that player, hey, I, the server player, I'm joining, so here's my position and direction, so you know that I exist. And then we loop through all the other players we have in the game. Well, there's this player, here's his position and direction, and send like, so basically we send the player join message to the player who just joined for every other player that's in the game. And then in the end, we send the player join message to all other players that were already in the game. Like, hey, this person joined. Check this out. So, and that way, all players will spawn everywhere on everyone's game. Or we get a message saying the position. In this case, I do not update. It's not the server object's duty to update the client's, the network player's position. The network player is supposed to update its own position. Here, however, if we do get a network message with the position, then our job as a server is to tell everyone else, hey, they updated their position. So we get a message and we send it back to everyone else as well. Okay? And for the client, same thing here. As a client, you also receive a bunch of messages. All your messages will come from the server. So you only have one person you're talking to. And to just be sure, because you can have other connections as well, we just put this here, but yeah, for now this wasn't needed because we only have one connection. We're not listening to connect or disconnect because we're handling that with the server other way. So we're just going to say, okay, if we're getting data here, let's sort it out. In this case, what we're looking for is player join. If a player joins, then we want to create that network player. The difference here between this and the other one is that we don't send the message through to someone else because we're just listening. We're just receiving information. If the player is leaving, hey, this player's left, then we'll just destroy that player. If the position is updated, okay, then we get that client and tell them, hey, this is the target position for this client. Yep. Words and stuff. And now for the network player. And this one is only used if it's actually the server. Because of performance reasons. Because since the client only talks to the server, all messages will come from the same socket, so it cannot quickly tell which network player is interested in this message. It actually has to go through and read the buffer, and that's a lot of work. Therefore, we do that in the object client instead of the object network player. However, for the server, since it has a lot of shit to do, it can spawn, look here directly like, hey, if it's a server, and if this socket, like if my socket, my network player socket, is the socket that's receiving this message, then do this. And in this case, I'm only interested in the position, because the player join message and stuff like that only comes when this object doesn't even exist. So in this case, if I get a message about, hey, position update, then I just store it in my target X, Y, and direction. What's that? I think that's basically it. Oh yeah, final one. And for the network player, first one. So in this case, in each update for the network player, we're gonna try to move towards the target direction. So we're gonna get the difference between the target X and the current X, and then take the direction and then figure out, okay, how fast are you actually trying to get there, based upon how fast you can run. So yeah, so we just try to figure out, are you moving slowly or fast towards that? And we don't wanna what you can do is even like decrease this like with 1%, just to make sure that you never arrive to your target faster than you can receive a new position update. Because as soon as you move faster than you're receiving messages, then you will have like the player moving, stopping, moving, stopping, moving, stopping, even though the player is actually moving all the time. So you always want to move slightly slower than the position updates, so that you're like moving, and then like should you start falling behind in the position updates, then you just I move a little bit faster, even though that's not allowed, but just so you can catch up with how the movement should be. And then you like when you're reaching the goal, you just slow down a little bit, and then like okay, so like you try to make it as smooth as possible. So based on if there's an urgency, you just we start moving towards this direction. And if we're really close, then we like just set X to the target. Otherwise, you can get a lot of like float issues. And if you're not moving, then we're idle. Very simple. And for the local player, similar thing, but instead like here we calculate our direction and urgency based upon which buttons have we pressed. So that's the main difference. Otherwise, it's almost the same code. However, if we are moving somewhere, then we're going to tell the server, hey, we're moving. Or if you are the server, you want to tell everyone else, I moved. Is this all? Maybe. Potentially this works. I'm just gonna do this. If it doesn't, then I remove too much code. Because the project is bigger than this, and I try to like take it down to the bare minimum. Let's create a zippy file. Yes, sure, whatever. Let's everybody pray to Lord Gaben.
Whoa.
First try, impossible.
So, like, there's sure this is local now, but it's still pretty decent. So it's like this can be done pretty fast, and if you want to try it, feel free to ask questions about it. But yeah, it's quite simple, and sure, I wouldn't use this when trying to make an esports game, but it's good enough to actually work and have a good multiplayer game. Thanks and stuff.